All right, ladies and gentlemen, hello and welcome back once again to the only coast to coast radio show in the US of A that's all about the information economy. It's time for Inside Analysis. Yours truly, Eric Kavanaugh, is here. And folks, we're going to talk about a very, very hot topic right now: how to get trusted answers from large language models. Because remember, they are generative. So the story is they hallucinate. They don't really hallucinate, they just confabulate. They make stuff up. They're designed to make stuff up. So when they have a lot of training in a particular domain, you can get a good answer pretty much out of the box. But when you talk about enterprise use cases like using an LLM for your business, well, then you have to give them the data they need in order to make the answers relevant and correct. This is a very hard problem, it turns out. So there are lots of ways people do these things. They use RAG models, we've talked about on the show, retrieval augmented generation, which is where you're basically trying to infuse some of your enterprise data into the context window to get back the answer that you want. That's a clever way of doing things. People use graphs, knowledge graphs. That's also a very clever way. What we're going to talk about today, though, is with a couple of experts in data integration, in data access, a company called Fivetran. So we've got Meel Velliste and Levon Korganyan on the call today. We're going to talk about federated data access and how you actually do this. And I guess you guys have a bit of a interesting product that you're launching as well. So Mel, I'll first throw it over to you. Tell us about this new product that you're launching that is really focused on this particular domain, and we'll go from there.
That's right. So the new product is called Triage. So it's not an official Fivetran product, but it's an experimental product that's being launched by the CTO's office. That's us. I'm Fivetran CTO, and Levon, he is a member of the office. And so we're launching this Triage product with a focus on support teams. This is something that Fivetran itself is using internally. And what it does is it enables our support team to get the answers they need from our internal documentation. Fivetran has so much product documentation and so much documentation about how to solve support cases and error
Hmm.
cases that might be relevant. And searching for all of that information using traditional tools is becoming more and more intractable. And so now with LLMs and with this kind of retrieval augmented generation, we can in fact get the answers, find them anywhere in the documentation where they may be hiding. And so with this triage product, we're opening up this kind of capability to other support teams at other companies for them to get answers from their documentation.
Hmm. Which is awesome. I mean, and maybe for our audience, let's break down a couple different paradigms here so they understand. Most people understand search. You index things and then you search for them either on your computer or on Google or some other place, and you're typically searching the index as opposed to the files themselves. So someone creates an index, a lot of that is baked into email platforms and all sorts of documentation. That's search is one thing. LLMs are a different thing. Now, with ChatGPT, it is doing a search. First, it shows you doing a Google search, so it's looking for information. And I believe what they're doing is they find relevant pieces of information, they scrape that text, they put it into a little cache, and then they run their summary algorithm on top of that. So that's not, I mean, search is part of that, but search is different from the generative nature of large language models. And so what you really want is sort of a hybrid model, right, where you're leveraging the power of search while also leveraging the power of LLMs, right, Mel?
That's exactly right. And so search is the thing that the LLMs don't have already built in, right? And so whereas things like ChatGPT now comes with a type of search, like they can do web search now. But when it comes to private company data, ChatGPT wouldn't be able to natively do that. Somebody needs to provide the capability, needs to bring that company data to the LLM.
Hmm. Well, and this is really important stuff. I remember I had this theory years ago, and I'd be curious to hear your thoughts on this for perspective. Google, of course, dominated search for decades. They're still a very major player, although they're now somewhat on their heels with OpenAI being so successful with ChatGPT. But I remember when Google went into enterprise search, and of course, they're not the only ones. You've got a whole bunch of different companies. Elastic, for example, is one. There are a bunch of different companies in the enterprise search space, and they all kind of had a hard time. And I remember saying that to a lady I know, a very smart lady, and then she laughed and smiled and said, "Yeah, I was on that team, and you're right. We had some trouble doing that." Why do you think that is? And what have you folks worked on to enable a more robust and accurate and governed kind of search capability?
That's a really good question. Why is it that those prior cases didn't succeed so well? Um,
I mean, across the board. Like, because, like, I'll
yeah,
just throw another thing and you can think about that for a second. But chatbots, I remember when chatbots first showed up on websites, and my theory was the reason they showed up was because search on websites was terrible. You would go to a website and you'd search for something and you'd get all sorts of irrelevant stuff, like basically from press releases and other things. Like, no, I don't want that. I mean, this is the use case that you're targeting with triage, which is
yeah.
being able to give access to a wide range of documentation about the business and then get back a meaningful answer, right? And of course, you guys at Fivetran are very good at data integration. You're very good at API access and all that kind of stuff. So maybe just explain how triage works. I think in doing so, you're going to kind of answer my question. So maybe go into the weeds a bit about how triage works and in filling this vacuum, which was
Um,
enterprise search.
yeah, I reckon the only reason the traditional products in this space didn't work as well is maybe because they couldn't have without the power of LLM type of technology. So,
Hmm.
yeah, what would you say, Levon?
Yeah, I'd say that's part of it. But beyond LLMs, there's also the advent of vector search. I think this was a huge technological
Yeah,
advancement, right? In the past, we were using all kinds of like really creative information retrieval techniques. We were using facets, we were using various signals, right? We were using text-based search, and that can get you only so far within
Hmm.
a specific domain.
Mm-hmm.
With vectors introduced, now we've almost steered too far into that direction, right? We've kind of lost some of the wisdom of IR, and that's kind of being reintroduced and recombined. But now search is
Interesting.
just better because of this new semantic capability that vectors provide.
Well, and I'll throw out just some thoughts, and I'd love to get your take on this, guys, because I try to explain to people how these LLMs work. And to your point, they convert language to vectors, which is it's mathematics. It's a point, an array in a certain direction for a certain length. And then in the vector store, where all this information is kept, you have cats over here and dogs over here. And what you're really doing is aligning vector arrays when you get right down to brass tacks, because the text gets converted to vectors, and then you do some similarity searches basically, and then it comes back and gives you your answer by converting it back into text. So people might ask, why would you do that? And I tell them because you can't crunch letters and you can't crunch images, but you can crunch numbers. And so that's why we use this process. It is a bit of a lossy process, and that's why you get some of the hallucinations. But to your point, Levon, it is a very powerful way to carve out a semantic space for a particular piece of content. Is that a good way to put it?
Yeah, exactly. And you can kind of get around the lossiness when you also stack on, of course, the full text search aspect, and you blend the results together, right?
Mm-hmm.
You may have heard the term hybrid search.
Mm-hmm.
That's what that aims to achieve. It's like not just leaning on the kind of lossy average semantic neighborhood that particular item fits in, but also exact keywords and acronyms that are relevant to your business. That's also considered in the result set.
Mm-hmm. Yeah, and hybrid search is the answer, Mel. I'll throw it back over to you. With hybrid search, you're really getting the best of both worlds, right? Because you're
yeah,
getting this semantic domain, let's call it, based upon the prompt and the training. And then with that text search, you're kind of getting the finer grain details, and that helps you get the accurate answer. Is that about right, Mel?
yeah. That's exactly right. And so, hybrid search is indeed what's under the hood of the Triage app as well. And so, um, And then a further step that that it takes is the LLM itself is then used to further distill down what's really relevant and dividing an answer to the question out of that. So if a person has a question that lies somewhere in the documents, what Triage will do is it will fetch, based on the hybrid search, a whole bunch of potentially relevant documents. And then the full power of the LLM is used to then wade through like the return snippets and to find what's truly relevant in all of that, and then dividing the answer out of that.
Yeah, well, and customer service is an excellent use case, especially when you're dealing with documentation, because historically, I mean, how many documents could you have? Tens of thousands that describe a piece of enterprise software with all sorts of fixes and upgrades and bugs that were solved and all sorts of different things. And there's a timely bias too, right? Because, and this has been one of my biggest frustrations in the old world with any kind of documentation about some problem in an application is that you have all this old documentation out there on the internet. It's everywhere. And so if you find one that's from 4 years ago, says go to file menu, go down to this, this option, and you're like, well, it's not there. And it's because the documentation is outdated, right? And that's a problem. So you need a recency bias in there. And you also need to be able to kind of follow the train of thought. And maybe, Levon, I'll throw it back over to you. It sounds like you guys have gotten very creative with Triage to have this multi-step process where it's doing hybrid search, but it's pulling in a nice compendium of relevant content and then using that to go do a deeper search and give you a more granular answer. Is that about right?
Yeah, that's right. It's a multi-stage process, and it incorporates not just say your customer support tickets. It also incorporates your breadth of business information and knowledge and definitions, right? So it understands typically how you would respond to such a thing, such a problem, and maybe historical, run books of various like instances of that same error that you've seen or that same situation that you're trying to solve for that customer. Well, this has come up before. It's in your documentation. Here it is. And that allows the AI to think about that and be primed to like help in the same sort of way, right?
That's wild.
I also want to add, by the way, that a big part of what makes Fivetran particularly well positioned to provide this kind of thing is that, like this kind of recency bias that you're talking about, that can only happen if the document set that's being accessed through this search is itself up to date, right?
Right.
And all of these document sets that we're talking about, they're not some sort of static archived collections. They're live document sets. And so in order for the search to yield the most recent answers, things that have just changed or been added or deleted, the data needs to be continually updated. And so that is, of course, what Fivetran is particularly good at and has been for years. And so it's the core of this continual incremental data sync that makes it so good. I mean, otherwise anyone can create some sort of a RAG thing, and there are indeed lots of companies offering some sort of RAG search and chat over documents. But what they're all missing is a really good layer that actually syncs the data from arbitrary sources. And we support hundreds of sources.
This is very interesting, and I want to dive a bit deeper into this because what I think is so fascinating is that, and again, this is what Elasticsearch was trying to focus on years ago, and what some of these other vendors are trying to do, and they've done some very good work. There's no doubt about it. But now with the power of these LLMs, and this intelligence, and that's a really interesting way a friend of mine put it. He said, look, this brings an intelligence. Just like someone walks into your office, you're not going to believe that everything they say is accurate, but you're going to parse what they tell you and use it in your own mind to better understand something. And he says that's how you need to use these technologies. They represent an intelligence. But what I think is so fascinating is that now you really can have this layer that allows you to reach into all the far corners of your enterprise information stack to come up with some answers. And there's a bunch of stuff in there that you probably didn't even know was there. And we'll find it'll be this sort of discovery process. But it really is, it's, in chemistry, they talk about a step change where it's not just a gradual evolution, it's like a revolutionary change. And Levon, maybe I'll throw it over to you. That's where we are now, right? This new layer, it is a step change from what we had before. There are some quirks. You have to vet things and be careful about it, but nonetheless, it is a major improvement to the way things were done before, right?
Yeah, definitely. And it's moving so fast. Just in the past year, there's been another huge paradigm change, which has been moving towards agents and giving the ability to the AI to trigger the search multiple times and iterate over the results it gets and digging deeper into certain terms, right? And that's been all made possible with this new protocol, Model Context Protocol, MCP, which I'm sure we'll maybe dive into today as well.
Yeah.
But yeah, just when I think back to how we started this year, the paradigm we were using was like totally different. We were using RAG that we had written in code, and we were like, okay, search across this document set, re-rank, give it to an LLM, boom, answer. But now we're writing these AI applications totally differently.
That's wild. I mean, to your point, and maybe Mel, I'll throw it over you. We've got about 1 minute left in this segment, but we are in a period of dramatic change. That's what I said at the beginning of this past year. I said we're in an era of hyper accelerated innovation, and that in and of itself presents a whole set of challenges and opportunities, right, Mel?
It really does, and I'm just really excited about all the possibilities. And I think that this kind of information retrieval and like summarization is particularly good application right now, because I think in this domain, really hallucinations are minimized because these LLMs they are generative, but they also get an understanding. And it turns out they're much better at like processing and understanding a bunch of documents where there's little to generate,
Hmm.
as opposed to trying to generate a bunch of stuff.
Hmm. How
And so,
interesting.
yeah.
Yeah. Well, folks, we're going to talk about MCP up next in the next segment, Model Context Protocol. I don't think I've ever seen a specific kind of product take off faster in my career. All of a sudden, there are like hundreds of MCP servers. All kind of different companies have them. So we'll get into the weeds of that next. Don't touch it, dial. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to a couple experts from Fivetran, an integration powerhouse. These folks, I started working with them back in 2018, and they are just a juggernaut these days. It's amazing how many clients they have, and they're solving that integration challenge. So you think in the old world, Informatica, Ab Initio, there are all kinds of different companies in this space, but Fivetran has really just made hay while the sun is shining, as they used to say in the old days. But let's dive now into MCP, the Model Context Protocol. It does what you think it would do. It gives context to the model. It has a protocol for delivering context to a large language model to help it get a better answer. So I'll throw it over to Mel Velliste first of Fivetran. Tell us, where did MCP come from? I know there were a couple major players that started this, and what are the nuts and bolts inside of an MCP server?
Yeah, I think Levon would probably better answer where it came from. I don't remember, but yeah, it was kind of something that came up, was tossed around by a bunch of companies, and it's becoming pretty standard now. And so yeah, it's just an arbitrary protocol for LLMs to be able to access data for their context, right? So.
And it allows, if I understand it correctly, and maybe Levon, I'll throw it over to you. The MCP is like the conduit between the LLM and your information systems. So you can connect the MCP to your databases, to your file systems, I suppose. And that allows the LLM to kind of reach in and grab something that's relevant and help it give the right answer. Is that about right?
Yeah, that's right. That's correct in the read-only use cases, right? But MCP also allows, it's really a function calling protocol at its
Okay.
heart, right? It provides a couple of different bits of functionality. It allows you to do things like read resources. So That was the first example brought up. But then there's also this idea of tool calling, which is an arbitrary function call. So it provides to the LLM essentially a method signature, right? It says, here's a function, here's the arguments that you can pass into the function, and here's what you would expect as a result, right? And its exact format too. And so the LLM is like, great, I can call this thing, and then maybe that function returns data, or maybe it takes action. It creates a resource somewhere. It schedules dry cleaning pickup reminders, right? But yeah, it allows LLMs to take action in the world, get the information they need, and act on it. And really, Mel mentioned that it's an arbitrary protocol. I think that's mostly true. This could have easily worked on top of REST APIs, for instance. But the power of MCP is in its adoption. And so when Anthropic, I think Anthropic brought it to market. Once it started taking off like wildfire, so many different data sources and data providers started to release their own open source MCP servers. But importantly, Anthropic's Claude added MCP functionality, and then OpenAI was like forced to follow suit, right?
Yeah. Once they did, I think all the floodgates really opened.
Yeah.
That's interesting. Well, and so, I mean, I remember on this show many years ago, someone made an amusing comment. He said, "Oh, in the IT world, we always believe that just one more layer of abstraction can solve all our problems." And it's kind of true, right? Because people who don't do code don't understand that in code, everything kind of goes around. You have a runtime and things kind of go around and around and around. So how do you get at things? And you have to kind of step outside and then go back inside in order to do stuff. And that's some of these function calls you're talking about. But the power of the MCP really is to give the ability to, as you say, to call functions, to do things that aren't explicitly hard coded into a particular application. So it can call in a number of functions and it can kind of figure things out. I mean, to be honest, one of the spaces I've never fully understood, and I keep trying to get to the bottom of it, is declarative programming in general. With imperative programming, you say step by step, do this. With declarative, you say, okay, I want this result. Go figure it out, system. The system then figures it out. And this is sort of a deeper layer of declarative programming in a sense. Levon, what do you think about that?
It's exactly that. So MCP is the declarative version of retrieval augmented generation, right?
Interesting.
Before MCP, before this agentic paradigm, we were doing imperative programming where we were making that search call in a little AI application, and then we were pushing those results into the LLM's context, right? But now we're saying, hey, LLM or coding agent or what have you, you have all of these tools at your disposal. I want you to do this thing, and that's what you're declaring. And then it goes out and does the thing, right?
Yeah.
It's a higher level of abstraction.
Yeah, which is just absolutely fascinating. I mean, it's amazing. Now, we're still in very early days with this agentic stuff. And, what I'm hearing from a lot of different experts in the field, and maybe Mel, I'll throw this over to you, is that you have to be kind of patient with them. But if you get it right, they could do amazing things. And you kind of set them off there. There are all kinds of tidbits I've picked up, like 8 hours is about as long as an AI agent can run, which I thought was kind of funny because it's like, oh, it's like a human. So at the end of 8 hours, it's like, all right, my day is done. You got to restart them. But they will run into some issues. And I think the real key is orchestration and monitoring and knowing what they're doing and what they have done. So you have to have these sort of, chain of command type things that go in, and you don't want them stepping on each other's toes. So that's where I think the real magic occurs. And I'm not sure if that happens in the MCP or if that happens somewhere else, but maybe Mel, just give me some thoughts on the nature of MCP and how it is allowing us to, again, it's almost like it's an intermediary between the large language model and your enterprise data. So as that sort of marshaling area, it's very valuable at being able to allow the LLM to get the specific pieces of context it needs in order to do the right thing. Mel, go ahead and give us an example of that.
So a lot of sources provide MCP servers to give access directly to data that like SaaS applications to the data they host. So, for example, GitHub has an MCP server that lets you connect your LLM to just GitHub data and get answers from GitHub. But then you have to connect all of the other sources separately.
Yeah. Yeah. And so what does GitHub's MCP do in that sense?
Yeah, so GitHub's MCP provides a search over some of the entities. I don't know exactly what entities they have. You can search over like actual pull requests and code, but also some of the metadata, but not all of it.
Yeah. See that, I mean, this is really interesting, and Levon, and maybe we can talk about this in the next segment. We've got about 5 minutes left on this one, but when I think about what's happening versus the perception of what's happening, there's still a pretty big disparity between those two things. And one of the myths I think is that, oh, a lot of these old, these old deterministic systems are going away. No, no, they're not. Databases are not going away. That's still the system of record. What we're talking about here is being able to access the right bits and pieces from systems of record in order to put together a story, to understand something, or to do things with these AI agents. I mean, they are actual worker bees that are going and doing things, and they're using the LLMs to get their instructions. But the systems of record are absolutely not going away. If anything, we now have better access to them and a better means for managing them. But to Mel's point a second ago, I think what's very interesting about Fivetran is what you're just describing is this sync of all the data and the data that's changed and even the indexes themselves, so that over time, anytime you log in and try to find out what's happening, you're going to get the latest because you've taken the effort to do that syncing, right, Levon?
Yeah, that's exactly right. And I'm glad you brought up systems of record, because ultimately the data that we're pulling from these source systems, they're not being, copied into an exact file replica, right? They're all being contributed to a data lake or a data warehouse, and they're all living there. And we actually transform the data in flight, right? So for instance, like say you search for relevant tickets, like support tickets, right, for a particular issue, you're going to get a rather denormalized kind of JSON type format from the API, right?
Mm-hmm.
But that has certain pointers to other records from other endpoints that need to be resolved. And the format in which that data is returned is actually not that useful for an AI until those things are resolved. So there is a certain
Interesting.
transformation that happens that we also manage as part of the Triage app, such that the data is documentized and maximally useful for the AI. It has like all of the context that it needs. And
Wow.
so that transformation is actually running uh, in SQL. We actually use DBT to orchestrate that.
Hmm.
And so there's a whole ETL that's happening. It's not just like, hey, we're pulling the data out of the API and putting it in a vector store. No, there's stuff that happens before that, before we vectorize, so that you can ensure that the search returns the richest context.
Wow. That makes a lot of sense because like data needs to be in a certain shape to be used by a particular application. And AI has its own predilections about how it wants to see the data. Certainly the LLM is just a big blob of text that goes in and a big blob of text that comes back. The question is what text goes in, and some of that you're pulling from either, again, through an MCP, from a system of record, from a graph. I think that's one of the more robust architectures I've seen, where you have your enterprise systems of record, you build a knowledge graph on top of that, you have an MCP up here, and then you have the LLM up here. That's a very rich, layered architecture that it's going to do a pretty good job of getting you what you want, right, Levon?
Yeah, exactly.
Yeah, that's some good stuff. Well, we got one more segment coming up here in a second. I'm fascinated talking to these guys who know the inner workings about how these systems work, because if you don't, you could be getting anything. I mean, I talked earlier about enterprise search on websites, and it was just horrible. I mean, it was just absolutely god awful because things weren't indexed properly, they weren't thought through properly, and if you don't do all that work, then you're going to have a hard time on the other end. So it's kind of like you probably heard this expression that simplicity in the user side requires a lot of complexity underneath to get them to where it's simple to use. And that's what we want. We want a system that is simple to use. And, speaking of complexity, think about how much the LLMs have changed in just a matter of 3 years. And we're coming up on the 3 year anniversary. I was talking, in fact, to Bob Muglia, and this is about two
Mm.
and a half years ago. He was one of the founders of Snowflake. And he was telling me they are fixing things so fast, it's crazy. He said, we had these problems, and all of a sudden they're fixed, and those problems, and they're fixed. It's like, wait a minute. So things are happening quickly, but folks, don't touch that dial. I'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, we're digging into the weeds here about federated data access versus synced data. And Mel Velliste, I'll let you take it from there. I remember from the earlier days in this whole epoch, things like Apache Arrow, which was all about federated queries. I think that's part of Dremio these days, or they're the ones who sit on top of that. But federated access, it really, I think, is the future because we went through this whole phase of data warehousing and then data lakes, just try to pull it all into one place. You're never going to get all the data in one place. So you want to be able to act in a federated manner. But tell us your opinion on federated and what you need to do to have meaningful federated data access and what that looks like.
Well, yeah. So my point about federated data access in the context of LLMs, right? So when you're trying to gather context for the LLMs, is that the federated access, I don't think it's going to work very well for the reasons that I mentioned in the previous segment, right? I talked about how there are impoverished search interfaces in most SaaS applications APIs, and those impoverished interfaces are the only things typically exposed through the MCP protocols to LLMs when they provide access to for LLMs to directly connect to a given SaaS application, right? So yeah, in theory, it would be really nice if LLMs could access all the relevant data through these direct connections to each of the sources, right? So like if I have 10 different SaaS applications that I use in my daily work, and if I can just connect each of those 10 SaaS applications to my LLM via MCP, and if I could get relevant data that way, if I could like get quality search results to the LLM, then it would be beautiful, right? Then the LLM can answer all my questions, right? And the reason it doesn't work is because of this, as I mentioned, these search interfaces are just typically not good. It's typically a full text search over just some of the entities, some of the properties, not all the properties of all entities, right? Whereas with the type of search that we implement in Triage is it's search over all the data, all the properties of all entities, and so it's something that we can implement consistently well, like full hybrid search over all the data, not only for one source, but all the sources, right? All the sources that are connected through Fivetran can have the same high quality search. Whereas with the federated access, even if, say, one source provides a really good search interface, like maybe they implement a good hybrid search on their backend over all of their entities, then that's great. Good for them. Good for that one source. But are the other 9 going to implement it? Probably not. And so you're just not going to get consistently good search results across all your sources in this federated world unless all the sources implement good search.
Interesting.
Maybe at some point in the distant future they all will, but I don't think that's going to happen anytime soon.
Well, it kind of reminds me, it's a bit of a far-flung analogy, but it reminds me a little bit of the challenges around MDM in the early days, master data management, because with the early MDM solutions, you really had to rely on teams following certain protocols to do things a certain way in order for the whole thing to work properly, and no one wanted to do that. And so
Yeah.
like you have to force it on them, which nobody likes, or you have to get them all to do the right thing, which never works. That's
Um,
that's kind of what you're talking about, right?
yeah, very much so. And I think there's more to it too, right? This problem is deep, right? Levon, I think, can talk about, for example, the importance of transforming the data the right way in order for this indexing and search to even work well.
Yeah. Yeah, Levon, I'll throw it over to you.
Yeah, so again, we want to resolve a lot of the bits of data that are coming in as pointers or IDs, right, from the directly from the API. And so that's where those transformations come in. Often, for depending on your application, you may actually want to join to data that's in a different service entirely. Like you may want to join to your internal database, right? You might want to resolve more, say, employee information based on the IDs that you're getting from I don't know what's like your Workday, right? Your HR
Hmm.
management tool. And so there is really a need for complex transformations that are can often be ad hoc depending on what application you're building, right? And so we were sold this promise of like if every SaaS provider just wrap their REST API in the MCP protocol and you could host that MCP server, you connected that all to your LLM, boom, now you can do anything. In practice, that's not really the case. Another reason why this is not really succeeding the way it was promised is because the LLM has a limited context window, right?
Right.
And
Right.
so there's a real scaling problem. Like, let's say the LLM is able to optimally figure out which tool will do the job, which MCP server will do the job, which in and of itself is a very difficult problem for an LLM if it's underprompted and the problem is underspecified. But let's say it does. When it gets those result sets back, that takes up tokens. That
Hmm.
burns tokens, and its context window gets smaller and smaller and smaller. The available tokens are less, right? And so there's a really limited runway. And at some point, the LLM providers also restrict compute. If they don't allow it to run indefinitely, right?
Right.
So it really has only a few shots of combining results from different tools before it sort of has to give you an answer. It's best guess. And it doesn't really have time to like navigate a complex API and do that resolution that I was talking about, right? And that's where synced data really helps, is that we can kind of pre-bake that data for you, compress it, and give you really rich context with minimal tokens used on the LLM.
That's interesting. Yeah, and so like one of the things I've heard, for example, is that Markdown is a format that LLMs really like. And
Mm-hmm.
if you use Markdown, you're basically greasing the tracks. You're speaking its language to a certain extent, right?
Yeah, that's right.
Yeah,
Yeah.
I mean, these are tricks. And maybe one last question I'll throw out, or I'm just guessing here. Ideally, what you want with these agents, and this is a pretty difficult challenge, but you want them to learn over time how to solve certain problems well, the playbooks that we talked about, and have that, if not hard coded, at least have it as a rule somewhere that it checks when it sees something. So, for example, you'll learn actually, yes, I can hit Workday, get my pointer data back quickly, as opposed to this other way. Well, you want the agent architecture to learn from that over time and know to do that because it can track things. It can know, well, when I hit this system, it usually takes 10 seconds. When I hit that system, I can get it in 2 seconds. This one's more accurate than that one. I mean, these are the kinds of variables that can be absorbed over time and understood, right?
Yes, but it is difficult to set up that feedback loop so that it
Sure.
does learn over time.
Yeah.
One way that AI application developers tend to get around this problem is they kind of shove all of these rules into the instructions, right? Into the system prompt of the AI. But
Right.
that means that you have to manually update these instructions over time
Interesting.
to kind of tune the behavior of the AI. And even still, again, as the usage of the context window grows, like let's say it only has 128,000 tokens it can use in its context window, right? Once it reaches about 50, 60% of that, where that's already occupied, it starts to misalign, right? It starts to ignore some of the initial instructions. It starts to kind of ignore some of the
Interesting.
results it's gotten.
Huh.
So in practice, this is a very difficult problem. And you might ask the same question 5 times and get different answers because the results are not stable, right? It's sort of non-deterministic, of course.
Well, I'm kind of figuring out in my head here why that happens. It kind of makes sense because it has X amount of fuel to use and it knows how many tokens it has. So you get to like the halfway point, it's like, oh, you got to start making shortcuts. Basically, it's like, well, let me just go ahead and do this and do that to finish inside of that range of tokens, right? So it's basically it's almost like it's under pressure, even though
Yeah.
it's really not. I mean, it's just trying to solve for what you asked it to solve for. And this is a consideration. And those context windows, that's a big deal. That's a very, very interesting challenge to have. And in fact, after this call, I need to connect you to someone who figured out how to solve that. Good buddy of mine who's been working on that very, very problem. I want to connect him to some smart people. But folks, look these gentlemen up online. Fivetran is the company, Fivetran. Meel Velliste, that's Meelveliste. And Levon Korganyan. Korganyan. Very, very cool technology. It's going to help you solve for your business needs with LLMs. We'll talk to you next time. You've been listening to Inside Analysis.